when we speak about thermal imaging inspection, how can we assure the accuracy of these results as environmental factors can influence the test?
Yes, definitely the environmental factors will affect the test, but the instruments what we use for internal, inside the building, outside the building, so it varies. So with respect to the standards which are maintained, so we keep that as a benchmark and we do it with the nearest accuracy of 95%. So we can give the report.
So my next question to Dr. Chandramouli. So when we speak about the adoption of SHM systems in the residential segment, how do you think this is viewed in India? Because I don't know if India is technologically ahead, or how's the adoption like from the homeowners and all that. That is one part of the question. And how do you think architects and builders can facilitate this adoption? Because ultimately people are getting it for, people may get one house or two houses their lifetime, cannot keep repeating. So how do you think that can be facilitated from the building stage, and how this awareness can be created? The first thing that we would like to know is in the residential sector, how adoptive are.
Let's go it in a, we'll go part by part. One is that the awareness, the first of all, the definition of structural health monitoring. Aren't we using health monitoring system in our residential buildings is the first question. Now, for that, why it is misunderstood is that the structure is very, in the structural point of view or the engineering point of view, it defines something else. From the normal layman point of view, it's quite different. Okay, so health itself, if we are talking about the health, means it could be something to do with the structure, how it is behaving or so. But health is nothing but the damaged state, whether it is performing better or not performing. So it is a so structural health monitoring is presently called as structural monitoring, to make it very simple. Now, in the residential buildings, what needs to be monitored is the next question. Now, in the large structures, there needs to be a lot of vibration that needs to be controlled because of the engineering efficiency, and we have done the designs most economical way and the most efficient way. Therefore, there will be a lot of compromises that would be taken care of. So, in order to understand that, whether we are compromised or not, we need some system in place. Now, take a look at the residential buildings. You in the critical climatic condition. Places where the temperature is freezing, you have the buildings monitored using temperature sensors as well as relative humidity, which is giving real-time, update, and as well as trying to keep the room into proper climatic conditions. So that is also monitoring. So in India, it is not, there is a lack of education on, firstly, the definition of structural health monitoring. The second thing is that the health monitoring exclusively or specifically on the structural vibration part, those are not happening because the small residential building are not more susceptible to the damages that are, when in comparison with the tall buildings or the buildings that are critical. So, but if you can see that these days we have smart houses, they are using a lot of sensors. Now, progressively over a period of time, these structural health monitoring systems, that is strain monitoring, which you are actually, I think you're more, specific on strain monitoring or the accelerometer monitoring. In the later days, we'll see those also plugged into our smart systems, and thereby it could be more helpful if in case you're looking for some type of changes that is happening. Now, you see that in India, the surveillance camera is extensively used. That itself is also a monitoring. What are you trying to monitor there? We are trying to monitor the surveillance and what is happening with the structure. Now you have to monitor, you have to use the cameras to monitor your cracks, but that's going to be a future days. There is going to be some accelerometers and the strain gauge that could be plugged in. Yes, yeah. So slow and steadily, people have started accepting the technology and the ease of access, and ease of understanding the technology. The ease of using the technology is what is required. You need to have a dash. Now you have the AI, which is quite a complex system to understand, but the results, what the user provides the prompt and what results is getting, it's quite understandable. If the user interface is quite understandable to any person, it could be reaching to every single individual houses and doors.
So my next question is for targeted repairs. How do you think digital twins can be integrated into building maintenance schedule?
Building twins, digital twins are basically 3D models which can be built using photogrammetry, using LiDAR data, And then you can add in some dynamic elements, which also include some operational information and so on. All of that gets captured into BIM overall these days. So if you are looking at targeted repairment, and then it really goes back to, do you take a life cycle maintenance perspective of your infrastructure? Now, if you are doing that, then you are, seriously collecting all of the information about the structure that you have on hand. And the digital twin makes it easy for visualization. So make it easy, again, when integrated within BIM, to collect historical data and keep adding maintenance, repair data, inspection data onto it. So that gives you insights that would very often, a very common problem is when you go to site to investigate a problem, is that you may not even find a drawing, for example, or you may not know even, what kind of structural design was done, if it's a 30 years, 20 years. Even in Hong Kong, sometimes we come across situations, or you find a drawing which is 50 years old and doesn't have sufficient details. So, so to address all of these things, the latest technologies like digital twin, like BIM, they become very, very useful. And I would think that it will help us to be much more, targeted, as you said, in our repair and maintenance, and reduce our cost, make it much more effective, and solve the right problems. That's how I think it will help you. It is basically in the maintenance management sort of perspective. Yeah.
Okay, thank you for that.
Mhm.
Okay, so I think by my another question to Mr. Balaji Singh, Dr. Balaji Singh. So you spoke about non-destructive testing. So in case of high-rise structures, which are like quite common these days, there are challenges associated with accessibility, like height, scale, and confined spaces, like ducts, shafts, wiring, etc. So how do you think, or how do you think these challenges can be overcome, and results can be accurate?
Yeah, I'll take it in say A and B. The A is high-rise structures. Yes, that is where the drone-based visual and thermal inspections. So that is applied so that high-resolution thermal cameras have been used. We use it so that we'll not miss out anything. And robotic crawlers for duct and shafts so that we can reach the places where a naked eye cannot go, nor we can check. And endoscopic cameras for buildings, which we are using, is giving us a very, very good reports. So it is like the endoscopy, what a human uh, 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 takes the complete details, what is there inside your body. The same way, a endoscopic camera, even up to go to 10 meters, which is crawling place, it can go and get the data for us. So we are using it extensively for our reports.
Okay,
Hmm.
anybody else wants to add?
Yeah, I mean, that is where I think the drone technology is becoming quite prevalent and quite sophisticated. Now, in fact, not only you can do visual and thermal inspection of building facades using drones, now you have advanced drones which can actually do some acoustic testing, can touch the structure, do impact echo tests and those kind of things. And then, of course, with metallic structures, you can even do thickness of coating measurements and all of that. So it does help to do a number of things. For example, I would love to see microwave to be drone mountable, which is not yet possible. But eventually, I'm sure it will be. GPR is being applied on drone mounted basis for large area scans. So in future, I do visualize that a lot of the accessibility problem for tall buildings should be addressed through drone-based technologies. Then at least we should be able to collect the data. Of course, we have to access the place to do the repair, carry out the repair maintenance. So there is no two ways about that. But the inspection part, at least we can avoid the dangers associated of climbing, tall buildings and so on to access. Yeah.
Okay, Dr. Chandramouli, you want to add anything? Yeah.
Uh, I always look for the technology, but drone and whatever we are speaking, I'm into core structural health monitoring issues that we develop a model based on these inputs. So most of the time, this becomes the fundamentals for us. And what the whole objective of is that the previous question, digital twin, we developed something called the finite element updating models. So wherein we collect these data from these technologies, that is, we use the inspecting methodologies, the assessment methodologies, NDT, NDE, and then the visual inspections that is carried out using drones and cameras, high resolution cameras. Now, the other side, no other side, the flip side of it is that although the drone can be helpful, the visual inspection gives us a real feel of it. Although it is very subjective, although my whole topic was to be very objective, but sometimes the complementing is very, very important. And the technology, what we are talking is that this is called static based. That is, you go collect it. It won't be of that real information that is coming up. There'll be a lag. But the health monitoring also has prevailed into something called real-time monitoring, which is not even online. It's almost much ahead. So the AI is pitching in these days, wherein we are taking the picture, the drone-based imaging system, and then understanding what is really happening in a structural system. That is also presently prevailing. So yes, it is extensively used.
So I would like to have a pointed question related to technology. So when they speak about tools like virtual and augmented reality, how are these allowing for remote consultations and in providing real-time guidance to technicians during complex repair tasks? So if somebody can explain that.
Yeah, I think, if nobody goes, that's obviously very important in this day and age. And in fact, like our platform that I was trying to show in Spectica at RaSpect, we create these 3D models, which are like a virtual reality model, which, when together with photogrammetry models and BIM models, they become very handy. So we are doing projects in Singapore, in Australia, whatever. So obviously we are not physically there, and people log in and they just see their building, they see the model of the building, they can zoom in, zoom out, go to any part of the building, see the exact defect that is there. Even rope access technicians, they can pull out their iPad or iPhone and check the defect that they need to check that the drone found. So they can double confirm. Singapore has a requirement for 10% of the facade must be physically confirmed through close-up inspection, which has been found by AI using drone technology, for example. So in those kind of situations, these models become absolutely critical, and they have to be accurate. Otherwise, you are hanging up in the air and you don't know where that particular crack is, and you're looking at some other place, unless these models are centimeter level accurate, So they're already very useful and being put to use in real life projects and problems. Yeah.
Dr. Chandramouli or Balaji, anyone wants to add?
Yeah, please, Dr. Chandra.
Virtual augmentation. Presently, it's mostly used in I'm talking about the Indian scenario. A few of the projects. Okay. Which is very new, and where new guys have hopped in and they would like to show their technologies. Yes, although it gives you a feel, how it is going to be. Understanding the drawing itself, we are still on the tables. Okay, and moving with the VR for repairs, it's still, it's going to be very soon. We'll be looking into it, but it's still in the construction stage only, where the new structure is being constructed, the model in a beam, and then that the virtual augmentation takes place at the site. Although it could be fascinating to see that, to understand the aspect, repair rehab aspect, ART, that is advanced rehabilitation technology and remedial engineering. When it comes to that, it's quite complex. It's very complex. And although the integrated part of BIM, it can work, but the way the physics works, the BIM is geometrical, but the physics, the way it is working with the physics of the materials and the other parameters, is quite tough to understand. I'm hoping to see such technology to be in the very near future in India, at least. I'm not aware of the other countries because I've not looked into the virtual augmentation part because it's a different sector. So I'm not aware. But definitely, I've looked when we are working with new projects, we have seen the augmentation taking place just to understand the feel of the structure and to understand how the architecture looks like and what are the requirements that is required from the other repair point of view, repair, or sometimes
Yeah.
the structures are not properly designed because of various aspects of BIM also. BIM also contributes to some of the errors which if it is not properly understood. So therefore, the augmentation sometimes will help us to understand and give us a better solution. Because we have the feel of it, although it is progressive. The structure you're designing and progressing with the construction. So this augmentation really helps us to understand, when we are reaching that point, and as well as go with the remedial actions.
Mhm.
Okay. So Dr. Balaji, you can add your points in.
Yes, the issues, the problems related to buildings are not stagnant. The decision making after giving the report, this is the issue. And by the time we take up the repairs, the time lapses and the defect would have increased more and more. So the problem, what happens is that technically, yes, already we have finalized, okay, this is the issue, we are going to solve this. But by the time we take up, it would have increased more. So commercially, it becomes always challenging when we take up the repairs. I think the other panelists agree with it because the time,
Yes.
the decision time, the gestation period the client takes, sometimes it creates issues. So the analysis while doing the work is very much essential, and hopefully we'll get the technology as early as possible. It will bring our
Mhm.
tensions less.
Yeah.
Okay. So another pointed question that I wanted to ask was, what is the particular technology or when we speak of foundation and to identify foundational defects, and because foundation is a very complex and
Yeah.
very critical aspect of a structure as such. So I would like to know the technology that can be used for the defect analysis of foundations.
These days, we are also able to use drones to monitor actually temporal data. So, for example, drones have become so stable. You can do a video recording of a structure over a particular period of time and actually construct the vibration of that structure, and monitor that from time to time, or from fixed cameras as well. Very high frequency imaging or video technology is also coming through, which is kind of a substitute to having accelerometers or other type of sensors mounted on the structure itself. So that is one aspect. But coming back to substructures, and again, those kind of dynamic structural behavior monitoring can give you clues about structural problems stemming from substructure subsidence or foundations problems and so on. Because substructures cannot be viewed directly, visually observed, visually inspected. So unless, of course, GPR is, again, to my mind, is of limited use. I'm not aware of many technologies unless there are sensors already pre-embedded in the substructure to give you direct information. You have to only get indirect information from the superstructure behavior in some sense, whether it's tilting, whether it's behaving in strange ways that can be easily correlated to problems from the substructure. But I think Dr. Singh probably has a much better idea and experience in that area. Thank you.
Yes, when it comes to substructures, yes, the historical data is very much important. Because we cannot just overall, we cannot say that substructure. Substructure is a very big word by itself. So we need to divide it into different areas. In each area, different elements. Is it related to rebars? Is it related to concrete? Is it related to leakages? Is it what exactly? Is the settlement? Is there anything? So structurally, once we analyze it, then when applied methodically, whatever the technology is available with us, supported by trained experts, yes, exceptional tools can get the defect, what exactly the issue, and it can be solved. But it has to go with the historical data. Without historical data, substructure is very, very difficult to monitor.
Investigate.
Yes, we face it, especially in
Always.
the marine environment. It is very difficult.
Mm, mm, mm.
Okay.
Yeah, yes.
Yeah. So basically, let's say we'll keep it more focused on some structures so that you will understand how it can be handled. So that would be giving you at least someone could understand uh, if in case it's quite closely related. It's like, if there is a structure and there is something underneath the ground, and it's like a blind man describing the animal.
Mm.
Now, if the blind man is quite sensible, he'll be able to sense what what is the description of that animal. Similarly, when it comes to a substructure, the superstructure should be supporting this is an indirect way of analyzing what is happening with the substructure. Basically, it's a geotechnical investigation wherein ground penetration radar could help, and various other wave testing that takes place, the shear waves and the seismic waves that is used and extensively used. If in case there is embedded sensor already, or the continuity of rebars is there, okay, it could help us to understand what is really happening with the corrosion. And if that is a scenario and you build a superstructure and you have some of the geotechnical inputs, a forced vibration or the ambient vibration can be used to pick up the signals and understand, have a basic idea on what is happening with the soil structure interaction. So with that interaction, we can minimize, I mean, we can, with a simplified version of that, understanding the interaction and using the simulation based, we can develop the models for understanding the spring element. The spring element is nothing but the substructure, which is right now assumed or understanding the datas and as well as the superstructures performance. With the inputs of the geotechnical parameters, we can develop the substructure model, which could be at least, it would give you, it could be quite, reliable for furthering, our analysis. This is the one way. If in case you're looking for some technology that wherein we can penetrate through, no, we cannot. I mean, there are possibilities, but again, it's case to specific. We recently had a investigation on a very massive structure wherein the substructure was even the bearing plates, the bearing platform itself. I'm not talking about the substructure. The bearing plate, platform itself had a lot of cracks wherein we were not able to lift the equipment. It was quite large. It was in about, I think, 100 tons to 200 tons, the equipment itself. So we were not able to find the base plate underneath the base plate if there is a crack because of the sensitivity issues. But when it comes to the substructure and the foundation, it's quite difficult. The only way is to retrofit it, assuming from the basics that there is no foundation existing, and further going with it. There are a lot of seismic isolation that is done in Japan, wherein the foundation is being dug and then the isolation system is being placed there. I think there are a lot of case studies that is already there. That will give you an idea how they will approach such type of scenarios. That will be a starting point for anybody who has got such specific case to be handled. So that is my input.
Okay, thank you for that vivid approach. So, when we speak of, tech or guidelines for structural health monitoring of structures in India, primarily residential structures, which are like very common in India. So, do you think there are any gold standards or any standards across the globe that has to be followed, or is there any particular country, or are there any particular countries which have already got these in place and which can be taken for India, or is it like the government has to come up with specialized codes or the guidance or guidelines for the Indian community?
Okay. So now your question is there any guidelines like for the health monitoring, which started with Evonics, that's Sivonics, now it is come up to Evonics, Metronics, Evonics, Metronics, and Sivonics. Now it's civil engineers. So basically, these people were just looking at each of the components and looking at its fatigue life. So every of the components and every of the specifics they're looking for has a coded provisions. Similarly, when it comes to buildings, you have your MBA, that is National Building Code itself, has got the limits of acceleration. Okay, that the comfort level. If you look into the ISO, I'm sorry, I couldn't remember the ISO number. If in case you need, I can text you that. There are ISO book and British standards that is extensively used for the comfort level, assessment. If in case you are having some vibration situation, you have the railway lane passing next to your building, and you would like to know whether it is whether it is really creating some issue in your building, or it is really disturbing your comforts, and or some construction activities that is happening next to your building, or you have a CNC machine, or you have some the costliest microscopes which is very sensitive to vibrations, like Singapore, they supply a lot of CNC machines and the microscopes, so these are very very sensitive to micro seismic activities or the micro tremors. So therefore, there are codal provisions that is given in British code or the European code, and as well as ACI, which is not completely dedicated to health monitoring, but specifics to the vibration limit and the comforts, human comforts. And if in case you're looking for in general for all the structures, there are SAMCO, there is a company called SAMCO, there are Canadian ISIS, which is already there. There is ISHMII, which are into, these are the association which you can look into for the case studies. They will refer to various materials and the various codal provisions that is already there. So we basically look into these codal books very specific to that particular limit, because in a code book we just look for the, okay, let's say this needs to be within this acceleration, we look at that particular specification, but that specification may not be exclusively for structural health monitoring. Because structural health monitoring, as I said, the health itself, the word health is having a different meaning. Let's say a very simple example. You may say that, as a blind man, if I'm a doctor, I'm a blind man, and I have a patient who's coming to me and says, I'm not feeling well, it can be a psychological issue also, okay, not just a health issue. So understanding or applying the relevant code books is not that easy. We need to pick up for that situation, we need to have to pick up that, we need to understand by a lot of discussions, a lot of inputs needs to be done. There's a Bayesian updating method, so we need to talk to the clients. Sometimes the sensors will not help, sometimes our technologies will not help. It is all the inputs that happens from the user, and as well as these users will give you the inputs. Based on their inputs, we collect the documents. Based on those documents, you have the reference documents and the codal provisions. Not exclusively that will cover up all the requirement for the structural health monitoring project, no. Definitely there is guidelines on structural health monitoring. It is by ISIS. I strongly recommend that guideline, and the SAMCO publications that are too good. And there are various other literatures or the reference books. But for the codes, there are codes on fatigue, there are codes on vibration, human comforts, and as well as machine foundation vibration. So looking into these, and as well as the tall building IS 456, if in case you're looking for, there also there is a limits of for vibration. You can refer to those, and you can pitch in and for the case specific, you can take that codal provision and then document it for your references and proceed with your solutions.
Okay, thank you for that. Any other thoughts from Dr. Mishra or Dr. Singh? You can please add.
Yes, when we are into home inspection, B2C, that is, we go to the base level and we do the checkings and inspections we do. Each and every test, we do around 300 tests we have in our protocol. So all the tests have got a norms and regulations and standards mentioned. So it is just, we need to educate the end user so that he will understand. Of course, the structural is a totally a different parameter. We have the code books and other things, but when it comes to a normal life leading human being, so we have the sound, the air, the HVAC, everything has got norms and regulations.
Okay, thank you for that. So I think we're now close to closing the panel discussion and the Q&A session. I once again thank all my panelists who have taken their time to be a part of this interesting session.